Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with the solution set for episode number 6 in our incredible new tutorial series where you're going to learn artificial intelligence or you're going to die trying. What I'm going to need you to do is pour yourself a nice, enormous mug of iced coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as always, as you're pouring your coffee, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's talk about what we are going to do in today's lesson. In lesson number 7, I taught you how to understand the data format for a picture or an image. And what I showed you is that really you can think of it as any other data set. It is an array. It is a two-dimensional array that has rows and it has columns, and at the intersection of a row and a column you have a pixel. For a grayscale image at the intersection of a row and a pixel, a row and a column, you have a pixel, and it is a single number, a number between 0 and 255. If it is a color image at the intersection of the row and the column, you find a little array that has 3 numbers in it. The first one is blue, the second one is green, and the third one is red, BGR. So you have 3 numbers to define a pixel. So I explained all that last week, and then I gave you a homework assignment to go in and use Python and OpenCV to create a checkerboard, okay? And if you really understood that slicing and dicing that we did with the numpy array function, then you should have been able to do this assignment. Now, what I need you to do is I need you to leave a comment down below and let me know whether you were able to do it or not. If you were able to do it on your own without watching me, leave a comment below. I am legend. If you were not able to do it, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay. Also, there was sort of like, you kind of like, a lot of times what I see is people don't want to really think through it. So rather than think through it, they just try to create a brute force solution because it's easier just to do things by brute force. But what you find is what you think is the easy way really turns out to be the hard way. And if you just think through it, you can see that there's a really simple and elegant solution. And so you might have done it the kind of sloppy way and watch me do it. And then you'll see, I think you'll see a real efficient and a very elegant way to do it. Either way, whether you're able to do it or not, by the end of today's lesson, you need to be able to do it on your own. So if you weren't able to do it without watching this video, at least then after you see me do it, turn the video off, go and do it on your own, because this slicing and dicing of numpy image arrays is something we're going to be doing for the rest of this series of lessons. And so if you don't understand it now's the time that you kind of like, you got to get this figured out before you move on. So if you don't understand it, go back, watch the lessons again, play with them. You got to understand this before moving on. Okay, enough of this introductory banter and chit chat. Let's jump in and let's get busy coding. So I will, that was very sloppy, wasn't it? Let's try that again. Much better, much better. I hate it when I have a abrupt scene change. Okay, so what I will need you to do is you have your coffee, and I will now need you to fire up your most excellent Visual Studio Code. And what we're going to do is we're going to come over to our File Explorer. I think the first thing we should do is to do a Control-Shift-P, and then we should do Python select interpreter. Now, why am I doing this? Because some of you guys are watching my 3D Python lessons. That's on a different version of Python, a different interpreter. This one, we're all on the same one, right? And the one we are working in is we are working in the Python 3.6.6 that is in our Pi AI 3.6 environment, or for you, whichever version of Python or whichever virtual environment that has the numpy and the OpenCV installed. Maybe you say, what is this numpy nonsense? If you installed OpenCV, part of that installation, it will install numpy. Okay, so now I should be on the correct interpreter. And then I will come up here and I will click on the Python folder. That's our working folder. I will click the little plus, and then we are on OpenCV-6.py, and the .py is sort of important. Just sucked a little coffee down my windpipe. Solution to that is more coffee. Okay. I think I'm back on track here. Hey, had a question in the comment on last week's lesson. Somebody was saying that if they came down here in the terminal, let me get out of your way. If they came down here in the terminal and they activated a virtual environment and then came up here and wrote a program, it wasn't using that virtual environment. And that's like, yeah, that's the way Visual Studio Code is. Your program up here is totally separate from this terminal down here. This is just a terminal down here. It's no different than if you typed command and got a terminal like this. Your terminal is totally separate from running a Python program here. And so if you came in and did something like Pi AI 3.6/scripts/activate, okay, and you activated that that virtual environment down here in your shell, up here it is still going to run the version of Python that you selected when you did Control-Shift-P. All right, it's going to use the one that you select here. So you could have one version of Python or one virtual environment that you're using in this top part of your window and a different one that you're using down here. But I can see that that could be very confusing. So now you understand that it's totally separate. But I digress. I digress. Let's get back over here and start writing this program. And let's write it the clean way. Let's write it the good way. Let's write it the way that you would if you are thinking like an engineer. I promise my throat will clear in a second. I'm sorry that I gulped that coffee down the wrong pipe. Okay, first thing we need to do is import our friend. Who is your friend? Your friend is Mr. CV2. Okay, and then what I always like to do, just for good measure, I like to print the CV2 dot __ version __, and then that closed that parenthesis for me already. Now I am also going to import numpy as np. Why np? It's easier to do np.this and np.that as opposed to having to write numpy every time. All right. Now, I want to kind of have a pretty generic program, so I don't want to hardwire in the number of squares on the checkerboard. I want to have that a user-defined variable. Now, if you look, a checkerboard has 64 squares. It's 8 rows and it's 8 columns for 64 squares, but I'm going to always have my checkerboard be square, but I'm going to give the user the opportunity to input how many squares across. And so what I'm going to say is, I guess what I would want to say is, I want to say board size, and board size is going to be equal to input, and then what size is your board boss. I like my program to call me boss because I'm the boss of the program, and so it's sort of like I like it when the program asks me and refers to me as boss. So that's one of those things I do in my programs. Okay, now when we input something from the keyboard, it inputs it as a string. So if I put the number 1000 in here, it's going to input it not as the number 1000, but as the string characters 1000. So we better go ahead and change that into an int. So I'm going to int that whole thing, and then I need to come way on out here. I need to close that int. So now I have a board size. Now I need to have like num squares. Okay, and num squares is how many squares like across or how many down. So it wouldn't be like 64 on the whole board. It would be like 8. Okay, so num squares is going to be equal to int, and I'm going to say input, and then I'm going to say, and sir, I like my program to call me sir, and sir, how many squares? Okay, and then question mark, and then I always like to put the space after that so it looks good. Okay, so we've got that, and then I think one of the things that you see already, and that is going to be that I need to know right off the bat how big the square is going to be. Now you don't input that, that's already defined. And so we're going to say square size is going to be equal to the board size, okay, divided by what? The num squares, right? So like if the board is 1000 and a square is 10, then if the board size is 1000 and I have 10 squares, each square is going to be 100. So we might as well go ahead and get that bookkeeping done, just because that is good form. That is something good to go ahead and have done. So now I've got the board size, I've got the num squares, and I've got the square size. And now what we can do is go ahead and say while true. When it's true, true is always true. We've just created a what? We've just created ourselves a nice little infinite loop. Okay, so now what are we going to do here? Now we're going to create the game board, the big board. We're not going to worry about the little squares. We're just going to create the game board, and I'm going to do that. I'm going to call the game board X. I'm going to say X is going to be equal to, remember, how do we create a blank numpy array? NP zeros. This will create the array and it will fill it with all zeros. But we got to tell it what size it is. Well, what size is it going to be? What size is it going to be? Well, it is going to be, I think it's not going to be board size, right? Or is it going to be board size? Yeah, it is going to be board size. So board size. And remember, the first number is rows. So how many pixels are we going to have up and down? Board size. How many pixels are we going to have left and right? Board size. Board size. Okay. So it's rows, comma, columns. And since it's square, it's board size, comma, board size. And now, if this was going to be a grayscale or a black and white checkerboard, this is all we would need to do. But since it's going to be color, we got to tell it at each pixel, at each intersection of row and column, there's 3 numbers. So I put comma 3, and that's going to be blue, comma green, comma red. So I have to put a comma 3 there. Now I have to tell it what data type. So I've got to put comma D type, comma D type. Man, this is really getting annoying. Let me see if I can make it smaller and that thing won't be. I think you can still read that, okay? So the D type, the data type, is going to be, we want it to be an 8-bit integer and an unsigned 8-bit integer. So that's U for unsigned, INT for integer, and then 8. An 8-bit unsigned integer. Now, what is that going to be? And in fact, that is going to be NP numpy dot. So it is the numpy function dot unsigned int 8. Now, why 8? Because 2 raised to the 8 is 256. Okay, and then if you have 256 numbers and you start from 0, your range is 0 to 255. Okay, and that's kind of how we typically define red, green, blue numbers, with an 8-bit number ranging from 0 to 255. And hopefully that makes sense. Okay, so now we've created our array. I think we could actually show it right now. Let's just do that to make sure that we haven't already made some sort of really silly mistake. So what I can do is a cv2.im show. And by doing this, my checkerboard, and then comma, what are we going to show? We're going to show x. Now, why do I like to do this? I like to do it so I can kind of run the program as I'm going, and if there's errors, we can find it. Okay, now we need to do a little bookkeeping so that we can end cleanly. And you remember how we do that? We say if cv2.wait key. Okay, and how long are we going to wait? We're going to wait 1. And if that is equal, that means that if we have hit a key, and if that key is the ORed value of Q, then we will, what? We will break. Okay, so this is just a clean way to exit the program by pressing Q. Now, what you also know is because Windows is all goofy, we have to put kind of a mask on that wait key data to clean it up a little bit. And the way we do that is we AND that wait key value with 0 XFF. That is 0, the number 0 XFF. And then that should allow us to quit cleanly. So let's go ahead and run this. What should we get? Well, since we're filling the array with all zeros, this should be a big, beautiful black box. Okay. I like this. It's saying, what size? Well, that's not good. I'll fix that now. What size? Hopefully you guys saw that when I did that. What size is your board, boss? Well, I want it 1,000 pixels. Okay. And sir, how many squares? You see, I'm boss, I'm sir. I should work in your royal potentate at some point. Okay, so how many squares? We're going to have 8 across. And then, boom, a big, beautiful black box. So we're going to quit out of that. So at least we've kind of got that simple stuff done. Now we got to go in and we got to put the squares in. All right. Now, if we're going to have squares, there needs to be 2 different colors. So we better come up here and kind of set our colors up. All right, so what we're going to have is, I'm just going to say, because I don't know, maybe we would want to change the color, so I don't want to say like red color and black color. So I'm just going to say dark color. We're going to have a dark color is going to be equal to something. And then we're going to have a light color is going to be equal to something. And then the actual color that we apply to a square, we want to toggle between black or between dark color, light color, dark color, light color. So I need a third variable to hold what my now color is. So I'm going to say my now color is equal to, all right. So now what do we want our dark color to be? Well, I think I want my dark color to be black. And notice that I can put this as a tuple, which is basically an array with the parentheses, or you probably could make it just an array with square brackets, but either one will probably work. But I like making it a tuple just because then I don't have quite so many nested square brackets. So the dark color is going to be 0, 0, 0. All right. And now the light color, let's make it red because that's kind of traditional for checkers, and it's blue, green, red. So blue would be 0, green would be 0, and red would be the most excellent 255. So red is full on, man. We're getting full strength red here. No playing around with these light pansy red colors. This is full blown red. And now color, we got to set the present color to something. And so let's say that we want the first square of our checkerboard to be black, so I'll just make it dark color. So when we apply my color to that first square, it is going to be what? It's going to be black. And then every time through the loop, I need to what? I need to toggle now color. If now color is dark, then I need to make now color light. If now color is light, I need to make now color dark. And as we go through the loop, we're going to be toggling this thing. All right. Now I like to, and let's see, we are now going to come back here in the for loop, in the while loop, and now we're going to build our for loops in here. All right, guys, I like to step across columns first. Okay, I like to step across columns first. So go across the columns, then go to the next row. Go across the columns, go to the next row. So which for loop is on the inside? The inside for loop is going to be, columns, and the outside for loop is going to be rows. So I'm going to step through rows. So I'm going to say for row in range, and which row do we start on? 0. And then which row do we want to go to? We want to go to, let's see, what would this be? It would be num squares. So I'm going to go from 0 to num squares. Right. Now remember, this goofy range function stops 1 before num squares. But that's where we want it to stop because we're starting at 0, so we have to stop 1 before. Right? It's that crazy counting when you start with 0 business. So we're going to step row through from 0 to num squares. And now we need to do what? We need to step what? Column in range. And then the columns are going to go what? Same thing, num squares. From 0 to num squares. It's just on this inside when we're indexing this way, when we get all the way across, then we increment row and we go to the next row. But we're going to end up doing num square rows and num square columns both. Okay, now this is the line of code where the magic happens. So we've got to do a slice. We've got to take that game board and we've got to slice off one little square. And so you got to kind of really think about this. So we're going to go X and we're going to create a slice. Now remember, there is a comma. And to the left of the comma is the range of row values from the start row, colon, end row, and then comma, start column, colon, end column. So it's start row, colon, end row, comma, start column, colon, end column. So where do we want to start? Well, we would want to start at the width, so it would be square size, okay, times what? Now remember, it's row, comma, column, so this is the row times the row. So that's where we're going to start, and then we're going to go to where to make this square. It's going to be square size times what? Row plus 1. Okay, so right, we're doing rows. The first time through, the row is 0, and 0 times square size is still going to be 0, and that's where we're going to start with that little square. That first little square is going to start here, and then it's going to go to what? Square size times row 0 plus 1, square size times 1. So it's going to be 1 square from here to here. Next time through, it's going to be what? It's going to start here, row is 1, and then it's going to go down to row 2 times square size. So you see it's going to increment that way. Now that is what we do to the left of the comma. That's the range that we want in row. Now we've got to do the range in column. Well, for that, it's still going to be square size, right? It's still going to be square size, but this time times what? Times column. And then same thing, colon, and we're going to go to what? Square size, right? Square size times what? it is going to be column plus 1. All right, very similar. Can you see that? Yeah, column plus 1. Now, I need to think if I need to warn you about anything here. The warning is proper use of parentheses. You've got to have row plus 1 inside of the parentheses because you want this whole thing to multiply by square size. Okay, now now we've identified a slice. Here's our game board, and we've identified a slice, right, of that game board. What do we want to do with that? We want to change its color. So this is going to be equal to now what? It's going to be equal to it's going to be equal to now color. Okay, so the first square is going to be what? It's going to be dark color, which is black. Okay, so now I'm going to have my first square is going to be black, which is what I want. Okay, now color. That looks good. Now, this is what we need to do. Let me make sure I closed everything. That looks pretty darn good. I like it. Okay, now what do we need to do? We got to toggle, right? So what do I do? If now color is equal to what? Dark color, and I better do the equal, right? Or we're going to really regret it. If now color is equal to dark color, well, in that case, what do I want to do? Well, I want to flip it. So now color would be equal to what? Light color. So if it was dark, I want to make it light. Okay, well, what if it wasn't dark? Well, then else, otherwise, then now color would be equal to what? Dark color. So if it's dark color, it becomes light color. If it's light color, it becomes dark color. Does that make sense? Seems like that's pretty straightforward. Well, and look at this. We have white space in our code, and we're just like at 27 lines of code, and we've almost got this thing working. All right, now, there is an error in here, but I'm going to go ahead and run it because this is a really over and over you're going to get this error. So I'm going to let it happen. I'm going to show you what the problem is and kind of how to troubleshoot it. So we're going to come in here, and it says, what is your board? What size is your board, boss? I want 1,000. Okay. Then how many squares, sir? How many squares? I want 8. Okay. And boom, I get an error, and the error is in line 18. And so this was this kind of complicated line here. And what is it saying? X of square size times row plus 1, square size column, blah, blah, blah. Slice indices must be integers. Okay, so what it is saying is like this is a slice here, right? What is it? This is a slice index, and this is a slice index, and this is a slice index, and this is a slice index. And it says that those all must be integers. Well, one of them isn't, and therefore the program crashes. Which one would be suspect? Well, it would be board size divided by num squares, because if it's not a perfect ratio there, certainly that would be a floating point number. And even if it was like 1,010, even though that's a round number, maybe when you divide it gives you a float. So we better, what is the number one suspect? I think it's square size. So if I do int here, then I'm sure that one's going to be an integer. Now this probably will fix it, but the other thing that you could do is you could come in here and int this whole thing, int this whole thing, int this whole thing, and int this whole thing, and then you would absolutely have it work because everything would be an int. But a lot of times OpenCV wants an int, and you'll have a float sneak in there, just like what you saw happen to me. All right, so let's run this thing and see what happens. Okay, what size is your board, boss? It's 1,000. Yeah, and once again, I erased something that time. Let's see, edit. This really annoys me. Like if I have my cursor up here, when it asks me the question, it types up here, you have to come down and click here. Okay, so this is going to be 1,000. Okay. I'm still Mr. Munchkin. I'm going to make myself not Mr. Munchkin. Okay. So now how many squares? I'm going to have 8. And denied. Denied. I did not get a checkerboard. I got stripes. I got stripes. What happened? What did it do? Correct answer. It did exactly what we told it to. We said to step across the columns and every time flip the color. When you get to the end column, then increment the row and step across again, and then increment the row and step across again, every time flipping the color. So let's look at this, and it's something built in there that you probably didn't really think about as far as a checkerboard. Let's start up here. You can see this, right? So I got black, red, black, red, black, red, black, red, black. You see it's black, red, black. It's doing exactly what we said. From this one was red, so the next one's going to be what? Black. But when you do that, you get stripes. So what do we need to do? At the end of the column, we need to flip, and then we need to reflip. We need to do a double flip. Okay, so after that inside for loop is completed and you're dropping out of the inside for loop, we reflip. Okay, so where would that be? Okay, this is our inside for loop, and then this is the stuff inside that inside for loop. And so if I just line it up here, right here, this would be the first line after the for loop. What do I want to do? I want to reflip. So I just do the same thing. If now color equal dark color, what do I do? And now color equal light color, right? And then I'm going to say else what? Else now color is equal to dark color, like that. All right, does that make sense? So we're going to flip. We get to the end of the column, and then we drop out of the for loop, and then we reflip. We double flip. All right, so now let's see what happens. I'm going to come over here and run it. What size is your board, boss? Well, son, I am 1,000 pixels. And sir, how many squares? Let's make it 8 for the traditional checkerboard. And Shazam! Look at that. Who's your huckleberry? I'm your huckleberry. Look at that. That is pretty cool. We have made a checkerboard. And let's quit out of that. Also now, because we did this kind of like really generically, we could come in and we could do it different. We could have dark color to be black here, and we could have light color. Let's make the light color kind of a gray. Okay, let's make it like a 175, 175, 175, like that. So that's going to be kind of like a light gray. And so it's going to be black and light gray. And now we're going to come in, and what size board? Let's say 1,000. And what if we did something crazy and said like 100 squares across? Let's see what that looks like. Whoa. What did I do? I put a period instead of a comma. Did you guys catch that? I hope you did. Let me take that nonsense out. Let's try it again. Okay. So we're going to say that blasted thing. Okay. 1,000 and then 100. Boom! Look at that. Isn't it funny? I don't know if this happens to you, but when I look at this, I start seeing like circles, almost like I'm seeing cubes come out. And then if I stare at it, I kind of get the magic eye. I don't know if you guys know what the magic eye is, but it sort of starts having that magic eye effect. And so this is kind of like, don't look at it too long. It might make you like start thinking strange things or something. But anyway, so that is what we did. And we did all of that in 30 lines of code, including a lot of blank lines. And so again, what I hope you see is that a lot of times if you'll just put a little thought into these things, you'll end up with a lot simpler solution. You should be able to turn, if you didn't do it on your own before, you should be able to turn this video off and go out and on your own develop this, because the whole point of this is to understand this slicing business here, understanding this slicing business here. Okay, guys, I guess I need to give you, let's see. So first of all, if you did this on your own, put in the comments, I am legend. If you were not able to, be honest, put in the comments down below, I folded up like a cheap Walmart lawn chair. But now I will give you another chance. Okay, I will give you another chance, and that is I will show you a secret word, because before coming in to make this most excellent video, you know what I did? I, in my garden, picked pineapples. And so that was my pineapple harvest today. Got some big, beautiful, lovely pineapples. And man, they are so sweet. They are delicious. And this is my man, Peter, who is my gardener. And he's very proud of the ginormous, deliciously sweet, wonderful pineapples that we are getting. And so the secret word for today is pineapple patch. Okay, so first of all, are you legend, or did you fold up like a cheap lawn chair? Second of all, the secret word is pineapple patch. And then I'm also going to have a movie trivia contest today, looking for the correct, the first correct answer. What classic movie had this famous line in it? Classic movie with this famous line. Row well and live. Row well and live is the movie line. What is the movie? Now, you can put trifecta in your comment if you got the homework done in your legend, and you know pineapple patch is the secret word, and you know the movie that line came from. Row well and live. Okay, that was a great movie line. Okay, guys, I hope you're having as much fun taking these lessons as I am making them. I really like doing these. I really like joining you guys. I really enjoy joining you guys on the premieres and kind of, you know, interacting with you in the live chats. I will one day try to start doing the live streams again. It's just right now my internet connection is a little bit spotty, and when it's good, it's great. But then there's times in there that I kind of can drop out for 30 seconds to a minute, and that would not work very well for a live stream. So I'm trying to take care of that. I really want to get the live streams going again. Really appreciate you guys for helping me out. Remember, thumbs up to the video. If you haven't subscribed to the channel already, subscribe. Like this and share it with someone else. Okay, let's try to get the word out. And it does really help me when you put a comment down there. It gives me a little bit of the old YouTube juice so that this video is recommended to more people. All right, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.